Okay, we're going on to topic 3 now of chapter 3, where we use those systems of equations that we worked with in the previous lesson to solve word problems. So there is a little pattern that goes on here. So that's what I'm going to help you with right now. So again, I would pause the tape and read the problems over, and then we'll summarize. Because there is a pattern to follow here. We have adult tickets, and we have children tickets, and how many tickets were sold? 420. So that's your first equation. Now, what do adult tickets cost? And this was the number of adult tickets sold. And children's tickets? That was the number of tickets sold. And how much was brought in? So these are the equations, and you can choose whatever method you want. If you were going to use elimination, you would have to multiply one of these, let's say this one, by a negative 5. And again, you might want to get rid of the decimals by multiplying each term by 100. Here you'd have to add 2 zeros. And again, if you want to eliminate this one, multiply each term by a negative 500 here. These would cancel out, or you could use substitution. A equals 420 minus C. Now, I'm not going to solve them for you. The answers are below. Just want to help you get your equations set up. In number 2, here this is a fella that plays the piano and has a tip jar on the piano. Pause it if you'd like to read it over. And in the jar there are 75 coins, either quarters and dimes. So we can use the number of quarters plus the number of dimes. We said together there were 75 coins. This is similar to this one. Now, what's a quarter worth? Well, 25 cents times the number of quarters, and a dime, 10 cents, and the total amount in there was $13.35. Again, very similar to the previous one. We just get rid of all of our decimals by multiplying each term by 100. We could use elimination or substitution. Number 3, here this fella is planning a blend of 2 kinds of coffee beans, and what we have to identify is the 2 types. He has the house blend that we will call H to help identify what we're talking about, and a Colombian blend that we will call C, and he wants to make up a mixture of 10 pounds. So the house blend and the Columbia blend make up 10 pounds. Now, what's the price of the house blend? And it's $4.25. What's the price of the Columbia blend? $6.50. And these, the price that he wants to sell it for, the blend now, is $4.70. And how many pounds? That's going to be 10. There are the two equations. Again, I would get rid of all our decimals. You can use substitution or elimination. Now there's a lot of algebra here, but what I want to show you is how to set them up. You'll have practice in doing the algebra to solve them. All right, investments. Here we're going to have some money. He's got two different types of stock. One with an annual yield of 5%. We'll call that one X. And one with 10%. Call that Y. Now, if they have this much to invest, well, this is the amount that you're going to invest at 5%. So we have X at 10%. That's your first equation. And we're seeing this pattern repeating as we go through these. So what is the X1? That's 5%. So this is the interest you'll make on the 5%. And on the 10%, you'll make 10% interest. And the interest you expect to earn is $340. Again, get rid of all your decimals, multiplying each term by 100. And again, elimination or substitution. Saline solution. This is for your chemistry labs. Rosanna's mixing up for biology, all right. 40% and 90%. So our 40% will be X, 90% will be Y. She needs 10 liters of 70%. So this is the number of liters of 40%. Y is the number of liters of 90%. And we say altogether that's going to be 10 liters. Now, what's the concentration of 40? Well, 0.40x of 90 is 0.90y. And you want to mix up a 70. 0.70 of 10. There are your two equations. And all of these now follow the same recipe. Get rid of your decimals, multiplying each term by 100, and solve them. Now for this next one, or the next two are very similar. Picture might be in order here. Let's do a little picture here. Now I've read these already. In fact, I've set up the equations. That's why this is going a little bit fast. What you need to do is to be able to set them up yourself. So hopefully you're pausing the tape to read it and then come up with some kind of solution. So here, this person is going to go upstream and then downstream. So the amount of distance covered going one way and the opposite way, the distances are the same. Now we're using the formula distance equals rate times time. So what we want up here is distance. This distance and this distance is the same. So we need a rate times time for this. Well, here Daphne can paddle for 3 hours with a 2-mile-per-hour current to reach her campsite. So what will her rate be? Well, we don't know her rate. Her rate is going to be R. But we know that the current is carrying her along at 2 miles per hour, just without paddling. So she's paddling at her rate for 2 miles plus the 2 miles per hour of the current, and she's doing this for 3 hours. So this is time times her rate. The rate that she's actually going is the rate she's paddling plus the speed of the current. This is a combination. Now it took her 9 hours to return to her starting point when she was going the other way. So here it would be her rate in still water minus, she's going against the current now, and this took 9 hours. So this is time times rate, which is distance. This is time times rate, which is distance. And we know this distance is the same. D equals D. So we're going to set this up in 3R plus 6. I'm going to actually do this one for you. 9R minus 18. I'm just distributing this. This equals each other. Going to bring the r's over to this side. They become a negative 3r. So this gives me 6r. And this gives me a negative 18 on this side, a positive 18, which gives me 24. So I divide both sides by 6. I get R equals 4. Her rate in still water is 4. And that's what I did to get it done. Again, if you're copying this down, which I strongly advise, you will pause the tape to get it done. Now the last one is train leaving a station. Again, a diagram would be in order. And then the other train leaves the station, traveling in the same direction, and they're going to end up the same distance when it catches up. So here this train is leaving at 80 miles per hour, that's its rate. The other train is traveling at 100. Now, this train that goes at 100 leaves 4 hours later. So this is going to be the time here, plus 4 hours, and then this will just be the time here. So the slower train had 4 hours extra. The faster train, we're just saying that's the time. Now we don't know the time, but we do know that this one took 4 hours less. This one you can think of had 4 hours more. So we're writing it this way. We don't put t minus 4 because this is the original time plus 4 hours. This one is the later time, just the time. Now what do you know? Well, distance is the same. So we have 80 times t plus 4 equals 100t. Here we don't need two variables. So this is going to be 80t plus 320 equals 100t. I'm going to subtract the 80 from both sides. We get 20t equals 320 and divide both sides by 20. We get t equals 16 hours. Now, if you put 16 hours into MATLAB, they're going to count it wrong. You might say, well, wait a minute, we got 16 hours. Well, they're not asking for hours here. They're asking how far from the station will they meet. So they want distance here. Well, what is distance? Well, distance is rate times time. And we know now that time is 16. So 100 times 16 gives you 1,600 kilometers. And that's the answer, and that's the formula. Now, I took just 17 minutes to do these 7 or so problems. That's just setting them up. We did these last 2, but again, they're going to take an amount of time to work them through. Hopefully you know the strategy of solving either using substitution or elimination. And the answers are given down here. And in MATLAB, when you take it, of course, they'll be helping you if you need it. All right, we'll be moving on.